Math quiz number 8. If you've gotten this far, you should already have a formula sheet and you should already have a calculator. Let's do some math. As always with these math questions, I do not own them. They are sourced off the open internet. This video is for educational purposes. Hopefully it helps you learn. Question 1. Determine the required chlorinator setting in pounds per day given the following. Steady flow rate of 5.5 million gallons a day. Target chlorine residual is equal to 2.5 milligrams per liter. The average chlorine demand is 2.5 milligrams per liter. A. 251 pounds per day. B. 195 pounds per day. C. 213 pounds per day. Or D. 229 pounds per day. Question 2. Your water plant feeds 25% caustic soda containing 2.67 pounds dry gallon for final pH adjustment. Historic records show your average dose is 6.5 milligrams per liter. An average flow is 310 gallons per minute. At this rate, how many 55-gallon drums will you use in 1 year? 24.2 drums, 60.1 drums, 88.3 drums, or 120 drums? Question number 3. An ion exchange softener contains 50 cubic feet of resin with a hardness removal capacity of 20,000 grains per cubic foot of resin. The water to be treated has a hardness of 300 milligrams per liter as CaCO3. How many gallons of water can be treated before the softener needs to be regenerated? Select the closest answer. A. 57,140 gallons. B. A million gallons. C. 570,450 gallons. Or D. 33,330 gallons. Question 4. Calculate the percent recovery of the reverse osmosis unit if the feed flow is 5.88 million gallons a day and the product flow is 5 million gallons a day. A. 88%, B. 11.7%, C. 82%, or D. 85%. Question 5. A single piston reciprocating pump has a 6-inch diameter piston with a 6-inch length of stroke. It makes 16 discharge strokes per minute. The pumping rate is how many gallons per minute? Is it A. 6 gallons per minute, B. 12 gallons per minute, C. 25 gallons per minute, or D. 47 gallons per minute? All right, so the answers, if I did the math correctly, are question 1, D, question 2, B, question 3, A, question 4, D, question 5, B. So let's see if I can solve the questions correctly. Here we go. Question 1. Determine the required chlorinator setting in pounds per day given steady flow rate of 5.5 million gallons per day, a target chlorine residual of 2.5 milligrams per liter, and the average chlorine demand is 2.5 milligrams per liter. Let's pull the known and unknowns out of the word question. What you know is you have a flow of 5.5 million gallons a day, a residual of 2.5 milligrams per liter, a demand of 2.5 milligrams per liter, and what you're looking for is your dose pounds per day. To find feed rate pounds per day, you need the dosage milligrams per liter times flow million gallons a day times 8.34 pounds per gallon. We need to find the chlorine dosage first. So you have your chlorine demand plus your chlorine residual, and that will give you your dosage. So you have your residual of 2.5 plus your demand of 2.5, and you get 5 milligrams per liter. So that's going to be your dosage. So you plug everything in, you have 5 milligrams per liter times 5.5 million gallons a day times 8.34 pounds per gallon? And the answer is 229 pounds per day. Question 2. Your water plant feeds 25% caustic soda containing 2.67 pounds dry gallon for final pH adjustment. Historic records show your average dose is 6.5 milligrams per liter and average flow is 310 gallons per minute. At this rate, how many 55-gallon drums will you use in 1 year? So we're going to pull our known and our unknowns out of our question. What you know is the purity of the caustic is 25%. Its weight is 2.67 pounds per gallon. The dose is 6.5 milligrams per liter, and the flow is 310 gallons per minute. What we don't know is how many 55-gallon drums a year we're going to use. All right, so our first step is we're going to do our feed rate pounds per day. So you have dosage milligrams per liter times flow million gallons a day times 8.34 pounds per gallon. So we need to convert our gallons per minute to million gallons a day. All right, so there are 1,440 minutes in a day, and we want to get this to million gallons. So we're going to divide by a million. And remember, what you want to cancel out goes on the bottom. So 310 gallons over 1 minute times 1,440 minutes in a day times 1 mg over a million. So you do your math, and you get 0.447 mgd. Now we can plug this into our formula. Your dose of 6.5 milligrams per liter times 0.447 mgd times 8.34 pounds per gallon, and you get 24.2 pounds per day. So next we need to convert to gallons of caustic. So we have 24.2 pounds in a day. The weight of the caustic is 2.67 pounds, so 24.2 pounds times 1 gallon over 2.67 pounds. And that gets you 9.06 gallons per day. Now we're looking for a year, so 9.06 gallons per day times 365 days in a year. And that gives you 3,306.9 gallons. Now it's asking how many 55-gallon drums a year we're going to use. So you divide 3,306.9 gallons divided by 55 gallons, and your answer is 60.1 55-gallon drums a year. Question 3. An ion exchange softener contains 50 cubic feet of resin with a hardness removal capacity of 20,000 grains per cubic foot of resin. The water to be treated has a hardness of 300 milligrams per liter as CaCO3. How many gallons of water can be treated before the softener needs to be regenerated? Let's pull our known and unknowns out of the question. What you know is you had a volume of 50 cubic feet, a removal capacity of 20,000 grains per cubic foot, a hardness level of 300 milligrams per liter, and what we don't know is how much water can be treated. Water treated in gallons is equal to the exchange capacity in grains divided by the hardness removed grains per gallon. To solve for exchange capacity, grains is equal to the media volume in cubic feet times the removal capacity in grains per cubic foot. First, let's find the exchange capacity. You have 50 cubic feet of volume, and you can remove 20,000 grains per cubic foot. So let's multiply those together, and you get an answer of 1 million. So now we can plug that into the exchange capacity. The next thing we need to do is convert the milligrams per liter to grains per gallon, and there's 17.1 milligrams per liter per grain per gallon, and we've set this up so the milligrams per liter cancel out. So 300 milligrams per liter times 1 grain per gallon over 17.1 milligrams per liter, so you get division, and you get 17.5 grains per gallon. So now we can plug that into our formula. So you have 1 million grains divided by 17.5 grains per gallon. The grains are going to cancel out, and that leaves you with an answer of 57,140 gallons. Question 4. Calculate the percent recovery of the reverse osmosis unit if the feed flow is 5.88 mgd and the product flow is 5 mgd. So our known and our unknowns, the feed is 5.88 mgd, the produced water is 5 mgd, and we're looking for the percent recovery. The formula for percent recovery is product flow mgd divided by feed flow mgd times 100%. So we have 5 mgd divided by 5.88 mgd. You do your division, you get 0.85. We're going to times that by 100%. And your percent recovery is 85%. Question 5. A single piston reciprocating pump has a 6-inch diameter piston with a 6-inch length of stroke. It makes 16 discharge strokes per minute. The pumping rate is how many gallons per minute? Say that 6 times fast. First, let's find our known and our unknowns. So what you know is the diameter is 6 inches, the stroke is 6 inches, and the pumping rate is gallons per minute. That's what we're looking for, our unknown. So let's solve for volume. So we have the diameter, so it's 0.785 times the diameter squared times the height. And remember, in water treatment, volume is in feet, so we need to convert. So they're both 6 inches, so there are 12 inches in a foot. So to get it to cancel out, you're going to put it on the bottom. So 6 inches times 1 foot over 12 inches. And you get 0.5 feet. So we're going to plug that into our formula. You have 0.785 times 0.5 feet squared times 0.5 feet. So do your math. And you come up with an answer of 0.098 cubic feet. Now we need gallons. Someone's in my house. So there are 7.48 gallons per cubic foot. And you want cubic feet to cancel out, it goes on the bottom. 0.098 cubic feet times 7.48 gallons over a cubic foot. The cubic feet cancel out. And you get 0.73 gallons per stroke. Now there are 16 strokes. So 0.73 gallons times 16 strokes in a minute. And you get an answer of 11.72 gallons. Closest answer is going to be B12. So there we have another math quiz under our belts. Hopefully you guys are doing good at the math and you're learning. Hopefully this helps you. Thanks.